Welcome to this channel. So it's been a while since I did my last video. Okay, let's get to business. So in this video I will talk about index notation. Now for those who are not aware of what this is, or index notation in simpler terms, I just put it as a way of expressing large numbers into short form or just simplify them. For example, if I have numbers such as x times x times x times x times x, and then if I was to tell a child to say what number was there on the board, the child would take a lot of time to express what he saw, what she saw. So it should be like, no, there was x times x times x times x times x. Now we don't want to waste all that time, so for it to be easy interpreted, we use what we call index notation. We can write this in just a short form. How? We look at the common number here, or the common variable, which is the common letter there being x. So we write x there, and then we count them. How many are they? 1 2 3 4 5. So there are 5. So x to the power 5. So this has been expressed in index notation. Yeah, just like, yeah, x to the power 5. If there are 2, say x squared, like p squared, musicians, right? All right, so let's get to business now. Now in an exam, you have to understand first of all what each one of these is. X, in our case, x is known as the base. X is the base, and then the 5 on top there is known as an index. 5 is an index. So in an exam, you're going to receive questions whereby they'll give you the base, and then the index is unknown, and then it is an equation. You have to find the value of x. Remember, x is very important in mathematics, right? Yeah, so you can be given a base, then index is unknown, and then you have to find it. Or you can be given the index, the base is unknown. For example, you can be given such as like 5 to the power x is equal to maybe a number there. Yes, we'll write it here. 5 to the power x is equal to whatever number they can write there, and then they say find the value of x. Or they can say, just as we've written here, they can say x to the power 5 then is equal to whatever number they can put there. Still, you have to find the value for x. So this one, we call this one as when an index is unknown. This one is when the base is unknown. So what are you supposed to do? Let me just solve this one question that intrigued me the most on when an index is not known. Let's look at this example. Ta-da! All right, so there's this tricky question here. Solve 2 raised to power 2 minus 4x minus 10 is equal to minus 9. So how do you solve such a question? We know that this is an equation, right? And we know this because it has two sides. There's the left side and the right side there. So we want to look at the value of x, which will make this whole expression that when we substitute it, this side will be equal to negative 9. What do? First step, I think you are familiar with this one. That is collecting the like terms, isn't it? So we just write our little solutions there. Solutions. Okay, I hope it's, yeah, that's SORULU. So I'll rewrite it. Say 2x minus 4x minus 10 is equal to minus 9. We start, right? So the first step there, as mentioned earlier, we have to correct the this is correct or collect. Okay, collect the like terms there. So we have 2 to the power 2 minus 4x. This negative 10 will go the other side, so it's going to be is equal to minus 9. It was negative there, here to be positive. All right, good. Okay, we're making progress. And then now we have 2 to the power 2 minus 4x is equal to, what is negative 9 minus, negative 9 plus 10? Those of algebra of integers, it's positive 1. So let me write it clearly here. 2 to the power 2 minus 4x is equal to 1. Interesting. So you understand that at this point now, we want what value can x be, so that when we substitute this whole thing, when we expand this whole thing, it will give us 1. Well, one of the rules that we follow is that we have to make sure that the bases are the same. So here, make the bases to be equal. So we make these bases here, the base is already 2 here, so we have to find a way of making this base here to be 2, in that when we raise 2 to the power, what we'll get will be 1. Can you think of any? Yes, any number raised to power 0, the answer is what? Is 1. So even when you say 1 million to the power 0, the answer is 1. So this one here can also be written as 2 to the power 0. Yes. So now let us rewrite this one and then replace 1 with 2 to the power 0, because the base here is 2. Yeah, I would have used any other number, 3, 4, 5, whatever number, but we want to make sure that the base that we put this side is equal to this base that is here. So we say 2 to the power 2 minus 4x is equal to 2 raised to power 0. So now I have the bases are the same. So if the bases are the same, that means that even the powers are also the same, because there's an equal sign here. It means that this whole thing is equal to this whole thing. What does that mean? It means that this 2 minus 4x is equal to what? To 0. So let us forget about the bases for now. Not for now, just drop them at this moment. So we're going to have 2 minus 4x is equal to 0. Remember, we are just concentrating now on the indices, on the powers. So collecting the like terms, we're going to have minus 4x is equal to 0 minus 2, because this one goes there, it becomes negative. Okay, so far so good. We are toward the end. Then here we are going to have minus 4x is equal to, I'm trying by all means to avoid shortcuts. So 0 minus 2, it's minus 2. Okay, you can pause the video and then finish from here. Okay, so here we're going to say negative 4, even here negative 4, so that negative 4 and negative 4 will cancel each other. They'll give us positive 1x, which is just x is equal to, then negative 4 into negative 2. We're going to look at the common denominator here, which is negative 2, right? So negative 2, it's 1 over negative 2 into negative 4, it's 2. And there we have it. So this whole expression that looked like this, yeah, this one. So the value for x, remember, is the one that we've just found, to say x is equal to 1 over 2, or half. Remember what we did? We first collected the like terms, then found that actually the right side there was 1. Then here we wanted to make the bases to be the same, so what do? Remember that here we had 2 as a base, so I wanted to write 1, or write 1 in a way that when we put 2 and raise it to the power, we wanted to look for a base that when we raise to a power it will give us 1. And since we are concentrating on 2, we said, okay, let us write the base to be 2, then we raise it to power 0, because any number raised to power 0, the answer is 1. Then after we raised it to power 0, then I had 2 here as a base, 2 here as a base, meaning that also the powers should be equal. Since the bases are equal, even the powers also should be equal. That's when I say that 2 minus 4x is equal to 0, because the power here is 2 minus 4x, the power here is 0. And then I concentrated on the power, and finally arrived at the answer. So if this is your first time watching this video, please like and click on the subscription button, and please let me know what you think about this video. Until next time, bye bye.